Hello, this is now section 3.5, which is about implicit differentiations. All right, so the idea here, before we really start about the implicit differentiations, let me first talk about the idea. All right, so let's say we know, well, if we have a function, let's say if we write something like this, y is equals to 3x squared plus 2, then basically we're saying, we're naming this function, or the name of this function, well, or we can say this function is in terms of x, right? So if x value change, then y value change. So here y value is a dependent variable, right? Because this y value depend on dependent variables, because this y value depend on the value of x. All right. And we can also write, like I said before, I can also write this as f of x is equals to 3x squared plus 2, right? This f is just a function name. I can write anything here. I don't have to write f every time. I can just name this function anything. And the reason I have x here inside is because this function is in terms of x. That's why I have x here inside, right? So instead of writing like this, I can also write this function, let's say y of x is equals to 3x squared plus 2. All right, so basically these two are same thing, right? Because yeah, it's not different, because it's just that instead of f, I have y, it's just the name of the function, right? And now also there is another thing. So let's say if we have a function, let's say y is equals to, again, 3x squared plus 2. Well, I can also write this as well. I can move this whole thing to one side, so it will, well, these two are same, right? Y minus 3x squared minus 2 is equals to 0, right? So basically these two are the same function, right? So if I, let's say if I use a method we have learned to find the derivative of this first function, let's say this first function, I can say that y prime is equals to 6x, right? Now, well, like I said, these two are a same function. So now I can also find the derivative of this function here using the implicit derivative, or let me just write ID, which means implicit differentiation. All right. So the idea here is I have to take the derivative of, well, all of these terms. So first here, I have to take the derivative of y. Basically here, I'm taking the derivative. So if we take, or into, let's write, well, we are trying to find derivative of y in terms of x, right? So here we are trying to find the derivative of y in terms of x. So here, basically these, well, you will see I'm doing similar thing. Well, there is nothing difference here on these kind of problems. So here I'll take the derivative of y, which will be just y prime minus 6, right? I have to take the derivative of all of these terms. So this will be y prime, this will be 6x, and the derivative of 2 is 0. So yeah, we don't have to write that is equals to 0. So that's why from here I get y prime is equals to 6x. It looks like I'm doing the same thing. It's just that instead of here, I take the derivative on right hand side. Here, I took the derivative on left hand side, but it looks like same, right? So let's do another example where you will see a clear idea of what I'm exactly doing. So let's see. Okay, so now let's see another example. Let's say I want to find, okay, let's say if we have a x squared minus y cubed minus 3 is equals to 0. So here, if I have y is equals to something to x squared plus 4 blah blah blah, then I can find y prime just using the power rule, right? If I have just y. But what about if there is y cubed in the equation? So this is where the implicit uh, differentiation is used. All right, so using implicit differentiation, I need to take y prime. I'll find the derivative of y in terms of x. All right. So what I'm going to do here is, well, first here I can take I can basically, because I'm taking the derivative in terms of x, right? So if you're taking the in terms of x, or if you're taking derivative in terms of x, then here I can easily, well, directly use the power rule. So from here I can say the derivative of x squared is 2x. Now, since I'm taking the derivative of finding y prime in terms of x, so here I have y to the power 3, right? So here, this y to the power 3, if I want to take the derivative of this, first I have to take the derivative of this whole thing, which means I have to, well, I can simply use the power rule for this whole thing. So I can bring this 3 down here, y square, right? And then after that, I can take the derivative of this inside part, which is y prime. So basically here I used chain rule that I talked on chapter 6 and 3.4. All right. So you can watch the previous video. All right. So I'm taking the derivative of this whole thing. So 3 y squared, and then take the derivative of this inside, because this y, like I said, this is a dependent variable. So this y is dependent on x, right? I told you guys that here, right? So this is dependent. Okay. And then after that, take the derivative of 3, which will be just 0, so you don't have to write that. All right, so since we're trying to find the value of y prime, so after this, we can just isolate y prime. So just move everything else on one side and just have y prime on one side. So, okay, so I can move this to other side, which will be negative 2x, right? And then divide 3y squared or negative 3y squared on both sides. So y prime is equals to negative 2x over negative 3y squared. So negative cancels. So y prime is 2x over 3y squared, right? So yeah, so this way we found the value of y prime, right? That's what we're trying to find, and we got the value of y prime. All right, so this method is called, so whatever I showed here, this method is called implicit differentiation method. Okay, let's do another one. Okay, so now here again, I need to find y prime using implicit differentiation. So again, y is a dependent variable. I don't have to say that. When you say, well, basically, when you see a function like this, you can think automatically that, okay, y is a dependent variable. Y is dependent with x, unless if the problem specify that. So if the problem is not specifying that, so the standard way to understand the equation is when you see y is a dependent variable. So here I'm trying to find the y prime in terms of x. Okay, so using implicit differentiation, okay, the first, well, since y is a dependent variable, so okay, first I have to take the variable, the derivative of this whole thing using the chain rule. First take the differentiation of the whole thing to y, and then take the derivative of this inside y, which is just y prime, plus, now since, well, this equation is in terms of x, so here I can directly use the power rule, which will be just 3x squared. All right, and we are finding the y prime in terms of x, right? That's why it's just going to be 3x squared plus the derivative of 4 is 0, so you don't have to write that. Now after this, again, is equals to, so the derivative of 0 is still 0. Okay, after this, just move this to other side. So negative 3x squared y prime is equals to negative 3x squared over 2y. Okay. Now here, well, let's say now I need to find y prime of, let's say, this function given y squared plus 2y plus 3x is equals to 0 at negative 1, 1. All right, so now here we need to find the exact value of y prime. If you look at this one, all it was asking was just to find the y prime. So we found the y prime, which is a certain equation, right? Now here, we need to find the y prime first. And once we get the value of y prime, since we know these 2 points, so I have to plug in these 2 points to that equation. So here, on this point, the first value is always x, and the second value is always y, right? So, okay, now let's first find the y prime, and then I can find the value of the y prime. So here again, first I have to take the derivative of this whole thing, which will be 2y, and then take the derivative of this inside, which is just y prime plus, okay, so since I just have y, I don't have anything on the power, so it will be directly just y prime plus the derivative of 3x, which is 3, is equals to 0. All right, so since I'm trying to find the y prime, right? So I have 2 y prime now here. I have y prime here, I have y prime here. Well, there is this extra thing, let's just move that to the other side. Okay, this is y. Okay, so let's just move this to the other side, -3. Now, so from these two now I can factor out y prime because I'm trying to find the y prime. So let's just factor out y prime, which will get, okay, y prime times 2y plus 2 is equals to -3, and then just divide this whole thing on both sides. So y prime is equals to -3 over 2y plus 2, right? So now since a point is given and it is asking us to find the y prime at this point, so now after this, y prime is equals to, at this point, at -1, 1, at -1, 1, and y prime is -3 over 2, y is, well, y is 1 plus 2. So this will give, the denominator will get 4, so -3 over 4. All right. So yeah, keep this in mind that if a problem asks you to find a y prime at a certain point, then you have to show this extra step. If problem doesn't ask you this, if it just says find y prime, then you'll get a final answer in this kind of equation form. Right? And one thing, now whenever you see this value, what is the meaning of this value? What is the meaning of y prime is equals to some value? So this meaning is this value is slope of the tangent line at this point. So which means, let's say, this is just a random equation, all right? So let's say this equation right here, just say this equation right here is something like this. I'm just making a random equation. And now what I'm saying is, let's say there is a tangent line that goes through this point. Okay, so this point is -1, 1. So here the slope of this tangent line here, slope of this tangent line is, the slope is equals to -3, 4. That's what, that is the meaning of this value. All right. Again, we need to find y prime of, so the equation we have here is x squared times y minus 3x squared minus 4 is equals to 0. At 2, 4. All right, so I need to find the y prime of this equation at this point. Okay, so after this, okay, so here I can, use, so basically I have to take the derivative of all of these in terms of x. So first I have to take the derivative of this. There is a multiplication here, so here I have to use a product rule. Right, so the first I can take the derivative of x squared, which will be just 2x, and the second equation will stay the same, plus, now the first one will stay the same, And the second one will be when you take the derivative of y, it will be just basically it means just y prime, right? Minus now the derivative of 3x squared, since we're taking the derivative in terms of x. So here I can directly use the power rule because I have x here, so I don't have to do like this extra thing because I'm taking the derivative here in terms of x. Okay, so here it will be 6x to the power 2 minus 1, which is just 1, so I don't have to write that, minus the derivative of 4 is 0, so again I don't have to write that, is equals to the derivative of 0 is still a 0. Okay, so now after this, well, since I'm trying to find y prime, so I have just y prime here, so I need to isolate y prime. So basically I need to have just y prime on one side and everything else on the other side. So, okay, first let's just move that to the other side. So that will be x squared times y prime is equals to positive 6x. And if I move this to the other side, it will be negative 2xy, right? And then after this, I can divide x squared on both sides, which will give us y prime is equals to 6x minus 2xy is equals to x squared. Okay, so now after this, since I'm trying to find the value of y prime, okay, so the value of y prime at this point is at 2, 4, the value of y prime is equals to 6. So first value here, first value is 2, so 6x, sorry, 6x or 6 times 2 minus 2 times 2 times 4 over x squared or 2 squared, right? So when you do a calculation, you'll get a negative 1 here. And again, the y prime or the derivative value, right? The derivative value is always, like I said here, the derivative value is always a slope of the tangent line at 2, 4. All right, so let's say, okay, after this, okay, just in case, as I said that, okay, this is a random equation, which is basically, okay, this equation is this one right here, right? And I'm saying that, okay, so this is a tangent line. This is a tangent line, means a line just touch the graph at one point, right? And this is a tangent line that goes through 2, 4, right? And the slope, well, like I said, the derivative value is always a slope of the tangent line at certain point, but here the point is given, which is 2, 4. So this is the slope, which is slope at this point. So the slope is -1. So can we find the equation of this line? Is it possible to find the equation of now this tangent line or not? Because I think you will see these kind of problem in the exam, or also on the homework as well. Okay, so what about the equation of this line? Well, it's algebra. I think I did this in chapter 1, right? The slope means m, which is -1. I know the value, or I know the point that this line is going through. So, well, all I have to do here is just use this formula right here. Y minus y1 is equals to m times x minus x1, which is point slope form of the equation. Right, so using point slope form, well, I know that these 2 points, so I can name these points as the first one as x1, second one as y1, right? So I can name these points first one. It looks like I have a look at this as x1, this as y1, right? So then I can find the equation, right? So y minus y1 is 4 is equals to slope I know, which is -1 times x minus x1 is 2, right? So from here, when I simplify the second one, this will give y minus 4 is equals to, if I distribute this -1, this will give negative x positive 2. So from here I get, okay, so I can move this to other side, which will give us y is equals to negative x plus 6, right? Okay, yeah, this is it. I think I covered whatever I think I want to cover. Yeah. Okay, yeah, that's it for this section, and I will see you now in another section 3.6. I still have 2 more sections. Let me write it anew. Yeah, I still have 2 more sections to cover. So this is section 3.5. So I still have 3.6 and 3.7. So the exam, I think I emailed to everyone. So the exam now 2 will be next Monday. So it will be over everything that I covered after exam 1. So it will be over 3.2, 3.2 to 3.7. Right? All right, so I'll see you in the next video. Thank you.